Hello everyone, this is Vahe coming to you with another installment of an ECE experiment that's online. Experiment 9X, that's the online version of experiment 9. And this experiment is about diodes, LEDs, and logic circuits made from transistors. As before, as in experiment 8X that you have done, I have a template for a report, and all you have to do is just follow the report, fill in the information by doing simulations, importing pictures, importing results, etc., and then save it as a PDF file, upload it to the appropriate location on Blackboard, and that will be it. Okay, so if you've done experiment 8, this is very much like experiment 8 in the submission and the overall process. So I'm trying to make it as painless as possible for you so that you will not have to depend on so many things to perform the experiment. Okay, so let's start. So this is the front page. Obviously, you will put your name, UIN, lab section here. And on the next page, we'll see where the experiment starts. So in the first part of the experiment, we'll do some diode testing. So what you're asked to do is you're asked to set up this circuit with a 5-volt voltage source in series with a 1K resistor and then a diode. And we're going to be measuring the voltage across the diode. So that voltage marked VD is the node voltage, is the voltage from there to ground. So that's VD basically of the diode. And the current through the diode, which we call ID. So what we're going to do is we're going to do this setup for 4 different diodes. And I'll show you exactly how to pick these diodes, okay, in this simulation. It'll be very easy to do so. And how to measure the results. And what we're going to do is we're going to have 4 different schematics for 4 different diodes. You'll insert the graphics of those schematics right in these locations. And then there's a table to fill out. So for each diode model, you have to measure VD and ID, fill them up, and you're done with the first part. Okay, so how do we set up the circuit? And by the way, I'm going to be sharing with you the sample files here. So you can start from scratch if you want to, following the video. Or you could just start from the existing sample file that I'll be sharing, and then you can modify it for your own purposes. So you can do it either way. Either way, there are not really too many components, so it should be fine no matter how you do it. But I'm going to give you those sample files to start you off. Okay, so let's go back to the circuit. Pretty simple. Voltage source, resistor, diode. I want to remind you that in the lecture, we have been using a shorthand version of this, and let me just illustrate that to you. So like when I showed a system like this, right, with a resistor and an LED or a resistor and a diode, same structure, really doesn't really matter. That 5-volt voltage source up there, remember, it represented the voltage from that point down to ground, right? Same thing here, right? When we modeled it, that voltage 5 volts with a bar, right? 5 volts with a bar on it. That's a shorthand for a voltage source that's connected from that top point to ground. So basically, this picture here kind of reflects that, what's really going on. Okay, let's start. Let's start drawing the schematic. So I'm going to start from scratch so you'll be able to see absolutely everything. And I'll try to tell you what I'm exactly doing with the keystrokes so you'll be used to it. Okay, so let's go over here. Let's maximize it. Let's grab a new schematic here. Click this button, new schematic, or you can say file, new schematic, or from there, okay? So now we have open space. We can put anything we like over here. Let's start with the voltage source. How do you get a voltage source? Well, you go to this little AND gate symbol. That's the component library, right? Everything pretty much is there. So you go here and you click on voltage, right? So here's voltage. Place it. And you want to put another voltage source, you can, but at this point, if you want to end placing voltage sources, right click, you're out of it. And remember, you can name this voltage anything. So this V1 is the name of V1. If you look at the lower left hand corner, you'll see the comments, right? So I can call that VN, V2, V3, VN3. As long as it begins with a V, it's fine. And remember, this is the value of the voltage source here. So that's this V. You can have to put a value here, a numerical value. So if I right-click that, right, as it says on the bottom lower corner, the right-click V to edit the value of V1. So right-click, and I'm going to put here 5 volts. Okay, let's continue. So let's get a ground symbol. So you get the ground symbol from here, or just type the letter G and you'll be able to place the ground symbol. So let's put it right here. Okay. Okay, let's continue. Let's get a resistor. Okay, so let's pick the resistor from here, or type R. Here's our resistor. Get a diode. Here's a diode. Okay, so we have most of our components and get another ground. At this point, it's just up to us to however wire it the way you wish, basically. So let me just show you that we can just wire it like this, right? A left click, click. I'm clicking with the left mouse button. I'm done with the wiring. Right click to get out of the wiring mode. You've heard me say these before, so I'm sure you're used to it by now. And now, you know, if you want to make it a little more prettier, you can drag things around. Like if I say drag, stretch the wires, right? To make it look a little more presentable, or the way you want it to look like. Something like this, right? And then the thing that we're going to use, actually, we're going to measure the voltage. So what I want to do is I want to take a wire and connect it from this point out here. Left click, and then right click to get out of the mode. I'm going to put my voltage here. You'll see in a second what happens. So right click to get out of this mode. And what else do I need? Well, I want to make this thing equal to, I believe it was 1K. So we're pretty much in business here. The only thing that we don't have is the diodes that we need. If you remember, there's different diode models. And I'm going to show you how to select that. Like, for example, how do you select the 1N4148 diode? Well, just go back here, okay? Go back to the picture. If you move your cursor right over, it turns into a little hand, like an index finger. At this moment, if you notice that if you, on the lower left-hand corner, it says right-click to edit the D1. So if you right-click, you'll get into this little window, and you'll see it says Pick New Diode. So click on that and look for 1N4148. And you can, you know, by clicking these columns, you can even sort by these columns. You know, right now it's just sorting by part name. So 1N4148 is right here. I click on it, I OK it, and there it goes. Now I selected 4148, and I'm actually ready to do the first part here, right? Because all I have to do for the first part is, number one, I'm going to insert the LTspice window here, right? So, you know, we'll do it a little later, okay, after I simulate it. But at this moment, your schematic is ready. You just have to run the analysis. And the analysis that we're running is called operating point analysis. So right now, as it stands, analysis is not defined, as you see me say many times. So if you go hit on the, click on the running man here, say run, a window comes with edit simulation command. It says what kind of simulation you want me to run. And what you want is the one at the far right, DC operating point. If you click on that, all this is going to do is it's going to put the words .op on the schematic. So do not erase the word .op on the schematic, because if you do, LTspice will keep asking you what kind of simulation command do you want to run, or what kind of simulation you want to run. So if I OK this, okay, the simulation runs, I get a bunch of numbers reported. Don't worry about this, because we're going to actually visualize it a little later. Just close this, and now we're pretty much ready to go. Okay, so just zoom out, and you'll see that the OP command is right here. And now we can actually go measure the voltages. Now, one way to visualize the voltages, okay, not the current, but the voltages, if you take your, after the simulation runs, take your cursor, right? How do you know the simulation runs? That white window pops up with the numbers that we just closed. That means the simulation ran. And you have like numbers available now. If you take your cursor and go over this little bar area, okay, you can even see that it says on the lower left-hand corner what the voltage is. But to visualize it, I can simply left-click with my cursor on the node. Left-click, and now you see the voltage, okay? So that's the voltage that we're going to write down right over here, right? You're going to write down 653.229 whatever millivolts, or 0.653 volts if you want to write it that way. What's about the current? Okay, so that's what you enter like right here for this mod. How about the current? Well, if you take your cursor, go right over the diode, it'll tell you what the current is. ID1, it says 4.36 whatever milliamps. That's the number you write under the diode current over here. So that's how you do the model. That's how you fill out the table from the results over here. Okay, and the only other thing you have to do is you have to really put in the schematic. And that one is really easy. Just go here, right? And you say Window or Tools, copy bitmap to clipboard, right? And then you come over here and you say paste. Done. Okay, and maybe it's too big for you, whatever. You can adjust it as you like. That I leave up to you. So maybe you make it a little smaller so that it doesn't take up the whole space. But you know, keep putting one for each of the ones that you create, right? And then, you know, look, my table moved. Okay, fine. You know, just enter it, go to the next page and make it look good, right? But for each of these, you're gonna enter in a voltage and a current that you get from the simulation, and you'll have 4 of them. Okay, you'll have 4 of them over here. And then, like, you know, how do you pick the other resistor? MURS 120. Well, you know, just go on the diode again, right? Go over here, right click, and then go to pick new diode and look for MURS. What was it? MURS 120, right? So where is that? It's gotta be somewhere here, right? I probably missed it. It's gotta be here. Or maybe I can search by part name. If I click on the first column, now it's alphabetical in the first, so I can just go to MURS and find it. MURS 120, it's right here. Okay, once I OK it, it's right there. Run the simulation, run. Okay, and then a new window pops up. Okay, so you close it, and there you go. Okay, it's pretty straightforward. It's pretty straightforward. Okay, so I think you'll find this quite easy. Now, next section. Now we're gonna work with LEDs. How do you do this? Well, the structure looks exactly the same, but you're gonna be picking the LEDs, right? So how do you pick the LED? Well, there's 4 LEDs. Oh, QTLP. What the heck is that? Well, I mean, it's pretty easy. If you right-click on this where the diode is, just pick a new diode. You'll see that under the column called type, right? LEDs are actually type of diode. So it says LED right here. So again, if you go by part number, right, you'll say, okay, QTLP. Where is that? Well, just look for Q. Okay, OPQ. It's right there. Okay, it's right there. You OK it, and right here, it has little arrows for the LED. Isn't that cute? Okay, so we're really ready to go. Just hit the running man again. Okay, and then close it, and there's your voltage, 1.76 volts. And what's the current? I put the cursor right on the diode itself, 3.273. That's what we're getting, right? And then what do? Well, you know, take the picture, put it here, and then fill the table. I think you'll find that pretty easy to do. I don't think you'll have too much problem with this. Actually, they're all very straightforward. As far as I'm concerned. Once you do one, you're going to be able to do all of them. Okay, so that's a second section called LED testing. And there's 4 of those. And now when we come to the this part, okay, we're going to do some transistor logic circuits where we have to take inputs and outputs. Okay, so how do we set these up? All right, so let's start with a new schematic. That'll look a little different, so new schematic. All right, so let's put this circuit together. The top of the circuit looks very much the same. We have us 5 volts, 330, and you have this bipolar transistor. There's a model 2N2222. Where is that coming from? And there's a voltage V in. What's that, right? But the structure is not totally unknown to you, because if you look at the lecture notes, for example, for these switches that we used based on the transistors, this is the kind of structure we had, right? We had this V in, right, through our resistor. That V in represents a voltage source. It's either 0 volts or 5 volts, right? That's what turns the switch Q on and off. Q meaning the transistor being operated as a switch. And then to the top of the transistor, there's a resistor going to 5 volts, which limits the current through the switch. Well, that 5 volt really is represented by this bar with the 5 volts. But what we really mean, right, is a 5 volt voltage source from there down to ground. Okay, so basically, this picture is telling you exactly that. Okay, and the 2 resistors are 330 ohm and 10 kilo ohm. Okay, so there isn't really too much difference here in terms of how we set it up. We're just gonna go pick up the parts and put them together. So let's copy some of that, right? So in other words, let me just copy and paste this. How do I copy and paste from window to window? You ever tried that? Let me show you that, okay? So what you do is you say copy. I grab this whole thing, right? So now we're in the copy mode, okay? But I'm gonna copy to a new, basically new schematic that I created. Just keep going until your cursor goes over to a new schematic, okay? And I'm right in there. Left click, I'm done. I know it's magic, right? But the reason I did that is because part of the circuit we're just going to reuse it. We're just becoming lazy. So by being lazy, I can show you some tricks. Okay, so let me cut this part out because we don't need that, right? And obviously this voltage is going to change. I can just leave it, right? But now it doesn't mean anything. Let me get my transistor, okay? So if I go to the components, I just have to go to the NPN, right? Where it says NPN is the NPN bipolar transistor. So if I go OK on that one, right, I can click and place the transistor any place that I like. And so this is the way it looks. All right. So now what I can do is I can take the voltage source and maybe drag it up a little bit, right? Take it and drag it up like that, and maybe I can take the ground and drag it up just to make it look like what it looks like. Take the OP. This command is important, right? Put it up there, and then the transistor, right, that can remain, but I need a ground. Okay, so I go get a ground from here, right, and then I can go and wire this thing up all the way through. Right click, it's by magic, everything is done, right? But now I need a 10K resistor and a VIN, right? So first of all, this resistor in the new circuit is 330, right? That's how you do that one. I don't have to tell you. You've done it many times, I'm sure. Get a resistor. Here's another resistor. I need to rotate it. Control R rotates it. Okay. Place it. Okay. And then I'm going to get another voltage source to act as this VIN. In fact, this VIN is going to be either 0 volts or 5 volts. But for now, I can even just copy from here, right? And then change it as I wish, right? So take it and copy it here. Right click, right? So all you do is copy. Or if you want, you can go get a new voltage source from here. Just go here, grab a voltage and place it. You can do that. Grab a ground, place it. Wiring is through here again, right? So now I'm pretty much set. Right click. I'm ready to go, right? I'm ready to go. But this number now is not valid, right? Until I run the analysis, this number in blue is meaningless. Also, I got to change this resistor to 10K. So right click on so it says R, 10K, and I'm in business now. Okay. So what this part of the circuit or part of the analysis asks you is, again, to capture the schematic and also to fill in this table, right? Make the VIN 0, which is logic 0, and calculate the output V out and calculate the logic output, right? Because logic output and the actual numerical voltage might be different, obviously, right? Like 5 volts is logic 1. And in fact, I put a note here. It says that voltages from 0 to 0.8 are considered logic 0, and 3 to 5 are considered logic 1. So if you get like 0.4, that's logic 0. 3.9, that's logic 1, right? It doesn't have to be exactly 0 or exactly 5. It could be, but it doesn't have to be. That's how logic circuits actually work, okay? So here, I'm not simulating yet. I hit the running man. Okay, now I simulated it. I close it, and I see, okay, my output is 105.29 millivolts, right? Or 0.1 millivolts. Well, that's a logic 0, right? You know, that's considered logic 0. So if I go to V2, my VIN, right? If I want to, by the way, I can change this V2 to VIN. I just right click here where it says V2. I can just call that VIN, right? So that's pretty easy to do, and you know you can do that as you like. Now you might realize that, okay, I'm doing this, but my transistor is not 2N2222. So this is like a generic transistor, but it's still acting like a switch, right? If I put a 0 volts here, right? If I put 0 volts here and run the analysis, right, and close here, you see it's 5 volts. So it is acting like what I expect it to act like, which is this is an inverter, right? 0 in, right? logic 0 in, logic 1 out, logic 1 in, logic 0 out, right? That's what it's supposed to do. So here I'm putting a 0 volts in, logic 0. I'm getting 5 volts, logic 1 out. But if you notice that on the analysis I chose 2N2222. How do I select that? Well, now you know the trick, right? Just take the cursor, go over the transistor where it turns into an index finger, right? Index. Right click, pick new transistor and look for 2N2222. It's the first one actually. Just OK it and now run the analysis, right? Run the analysis for 0 volt input. I get a 5 volt output, okay? So that's still as before. If I put in 5 volts, okay, here, and run the analysis, okay, close the window, 80 millivolts, so 0.08 volts. It's a little different from what we got before, but very similar. Anyway, there you go. That's how you can do the circuit for the simple inverter, right? That's what this thing does. So again, as before, you know, for each of the circuits that you do, simply copy the schematic to the clipboard, for example, and then Control V to paste, or paste to paste, whatever you want to do, right? Whatever you want to use, and maybe make it a little more reasonable like this. There's only one circuit here, so you just move on, right? And you just put in the what you get for this table. It's pretty straightforward. But it tells you how to do these things in general, okay? So the circuits that we're using to do these things are very simple, but what you can do with it, you can do a lot more complex things using the same ideas that you're learning. So you're learning quite a bit in terms of how to deal with the circuit simulation tools. Okay, so what's next on the agenda? Keep going, keep going. Oh, there's another circuit. Okay, so what is this? This is actually an inverter followed by an inverter, right? So we have like the circuit that I had before, and we follow with another identical circuit. What happens then, right? So I won't do this. I'll leave you for you to hook it up. But just to note, the output of the first part is the input to the second part, right? And you're asked to fill out this table. Yeah, it's pretty straightforward. I think you should be able to do this, right? I'll give you a little hint, okay? What you can do is be kind of lazy, right? What you can do is you can just kind of copy and paste, right? Like, I mean, not that you couldn't do that, right? Just go to copy and, you know, copy as much as you can from one side to the other one. Oh, not everything carried. Not a big deal, right? But the output of one is the input to the other one. However you want to draw it is fine, right? All you're going to do is, you know, you're going to grab another 10K maybe from here and put it over here. And then you're going to take the output of this one, right? And take the output of this one and make it the input to the next one like that. Okay, and then this has to also have 5 volts. Okay, right there. You're done. Okay, that's this, isn't it? Pretty much. Was that difficult? No. Okay, but these values that we're seeing here are not current, right? No pun intended. We have to run the analysis. Rerun the analysis. Okay, close this, and you got the new values now. And you know, change the voltage here to 0 volts. Okay, rerun the analysis. Okay, and then here are your new values. Enter them in. Right, enter them into the table. I mean, I'm already doing it for you, so you know what you're gonna kind of get. But I want you to do this, right? You should be able to do this. You know, and then grab the schematic, right, from tools, copy, paste. It's so easy. If you know how to do it once, you can do it 10 times. So, the practice is what you need. Okay, practice is what you need, and then you can scale these as you like. You know, move the tables around. You know, okay, this is on the bottom. You know, maybe you enter a couple of times, move it to the next page. You know, make it look good. Make it look good, right? So your TAs won't spend too much time grading your papers, okay? So here it says Transistor Logic Circuit 3, you know, that you move to the next table, right? Or next page. What's the difference here? Well, now you have 2 inputs, okay? So, and they're in parallel. And there's a logic circuit number 4 in which the 2 sections are in series. So here we have 2 inputs, V in 1, V in 2, and 1 output, V out, right? Same thing here, okay? 2 inputs, V in 1, V in 2, 1 output. The only difference is these 2 switching sections are in parallel, whereas these 2 switching sections are in series. Okay, how difficult is that to put together? Not difficult at all, actually, right? Not difficult at all. So what you're going to do is you're going to cut and paste a little bit, maybe, right? Like, for example, if you cut this section here, okay, and then maybe if you get a copy, maybe this voltage source right here. Sorry, if you can copy, let me zoom out a little bit so you can see it. So I'm going to copy this voltage source over here. Now I have, like, if you want to call these VN1, VN2, it's fine. Maybe call this like VN2, okay, if you like. All right, call this VN1, okay. Now I have basically, going back here, I have basically this bottom section, but the top section, right, they connect together and we have one 330 resistor to 5 volts. So really, I don't need this one. Like, I don't need this one at all. But what I need to do is I need to connect this point right here to this point, right? And then maybe cut this extra part off. And now, I mean, if you just take a look, right, I think we should be in business, right? If you kind of compare these side to side, right, I think we're ready to go, right? So we have VN1, VN2, Q1, Q2, right? Those are there. I have one 330 up to 5 volts. That's okay. And all I got to do now is fill out this table. And as you can imagine, because we have 2 inputs, we have 4 combinations. Okay, so you're going to go through 4 combinations, right? Like, for example, the way I have it set now, VN1 and VN2 are both zeros. That's the first row. Okay, run the analysis. Okay, run the analysis. And then look at the voltage here. Okay, what is it? 5 volts. Well, V out is 5 volts. That's logic 1. Okay, keep doing it for the other cases. And at the end of each of these things, there's always a question asking you what type of logic function, if this is the input, this is the output. You should answer those as well. And, how about this one? They're in series. I'll let you do that, okay? And answer the questions. So this should be pretty straightforward because it follows what we learned, but we get to actually analyze it, okay? By trying different things, learning different options in LTspice. This is very, very invaluable. This is really good to know because you have to know how different kind of components are used and analyzed and evaluated, okay? So this is based on the things that you know, based on things that you expect. And, I'm hoping that this is useful for you. Okay, so I think I'm going to stop here. And by the time you get this, video and watch it, the supporting documents will be out to you. You would have received an email and so on and so forth. So you should be ready to go, basically. All right, so I'm going to stop here. Thank you very much. And I hope to talk to you very, very soon. Bye-bye.